Building Blocks and Historical Timeline of Machine Learning and Artificial Intelligence by Adam Khoury. In this video narration, you can learn about the history and core programming that resides under the hood of machine learning and artificial intelligence. This will help demystify how AI operates and how we arrived where we are today. Machine learning emerged as the human desire to automate thinking and predict outcomes based on experience. And the sections that we'll run through are 1. The Precursors, Ancient Concepts. 2. The Theoretical Dawn, 1940s through 1950s. 3. The Early Networks and AI Winters, 1957 through 1990s. And then finally 4. The Data and Deep Learning Revolution, 1990s through the present. 1. The Precursors, Ancient Concepts. The idea of predicting or automating knowledge predates computers. First, human. The root is human observation and pattern recognition, learning from experience to survive. For example, predicting animal paths or the weather. This is the core concept of machine learning. 1763. The first script, math. The introduction of formal logic and probability. For example, Bayes' theorem established the mathematical foundation for calculating probability based on prior knowledge, which is crucial to many machine learning algorithms. And if you ever had the need to try to explain this to a 10-year-old, you can try like this. You tell them it's like being a detective who updates their guess after finding a new clue. And the formula has 3 parts. Number 1, the starting guess. Prior. This is what you already believe. You think there's a 50% chance a hidden monster is in the woods. The second part is the new clue. Evidence. This is the new information you get. You find a giant footprint leading away from the woods and toward a cave. And the third part of the formula is the updated guess, the posterior. This is how you change your belief because of the clue. Now you think there's a 95% chance the monster is in the cave. Bayes' theorem is just the math that makes sure you update your guess in the smartest possible way when you get new evidence. And that's how you can explain it to a child. 2. The Theoretical Dawn, 1940s through 1950s. The ideas transition into a computer science context. 1943, McCulloch-Pitts neuron. Warren McCulloch and Walter Pitts created the first mathematical model of an artificial neuron, laying the groundwork for neural networks. Walter Pitts, mathematician, is on the left. Warren McCulloch, a neurophysiologist, is pictured on the right. Then comes the Turing test in 1950. Alan Turing proposed a test of a machine's ability to exhibit intelligent behavior equivalent to or indistinguishable from a human. 1956, Dartmouth Conference. The term artificial intelligence was officially coined by John McCarthy. It marks the formal birth of the field of AI research. 1959, the term machine learning is coined. Arthur Samuel of IBM coined the term machine learning while working on a checkers playing program that improved its strategy the more it played. Section 3. The Early Networks and AI Winters, 1957 through the 1990s. Initial excitement was followed by stagnation due to hardware limitations and unmet expectations. In 1957, the perceptron was conceived. Frank Rosenblatt created the first working model of an artificial neural network, a linear classifier. And you can think of a perceptron like a little judge, where it gets training data and iterates over that training data however many times you set. It's called an epoch. It runs a series of epochs until it can judge a correct answer. And it has something called weights and bias that help it come to a decision. 1974, Backpropagation. The algorithm essential for training multi-layer neural networks was published, though its importance wasn't widely recognized yet. Paul Werbos, who first described backpropagation, in his 1974 PhD dissertation. 1970s through 1980s was the AI winters. Funding and interest dried up as machines couldn't handle complex real-world problems. It got a little bit stagnant for a while. Section 4. The Data and Deep Learning Revolution, 1990s through the present. The combination of the Internet, big data, improved algorithms like backpropagation, and cheap, powerful GPUs unlocked modern machine learning. 1990s. The shift to data-driven machine learning. Focus moved from symbolic AI, rule-based, to statistical, data-driven methods like decision trees, random forests, SVMs. 2006. Deep learning coined. Geoffrey Hinton and others introduced algorithms for effectively training deep neural networks with many hidden layers. And I think this is one of the gentlemen who is called the godfather of AI. And I think I've seen him in modern YouTube videos where he's warning people about the dangers of artificial intelligence. 2012 through 2017, deep learning triumphs. The power of deep learning was demonstrated in areas like ImageNet, image recognition, and AlphaGo, strategy game AI, proving the technology's effectiveness in solving complex problems. 2017, the Transformer Architecture, and this was one of the most critical and crucial breakthroughs that gives us what we have today. A new network design introduced the attention mechanism, allowing models to process all input data simultaneously and in parallel. This programming breakthrough unlocked the massive scale needed for modern language models. 2018 plus. Generative AI era. Fueled by the Transformer Architecture, the field shifted to creating large, powerful models like GPT and Gemini, capable of generating high-quality text, code, and images. Today, which is the day that I drafted this outline, November 30th, 2025, now we're currently living in the time where AI tech companies are in serious competition to outperform their peers in that industry. There's a race for the best training data approaches. There's also a race to find or invent ways to feed their energy-hungry new AI systems because the current energy infrastructure in every country is not up to the task yet. Training data quality is generally considered more important than the underlying code base, the model architecture and training algorithms, for achieving the highest performance in modern AI systems. So what's going on today is that there is something called junk food training, where people who are building modern models, they're trying to weed out the junk food and get high quality training data. So what's going on under the hood in the programming is really not as important as the training data in the modern era. It's almost as if the brain is built, but now what you teach the brain is the important factor. And in conclusion, I have a little section for web developers here. And I have a new AI category at my website, and that's why I've created this video narration about the history and the programming building blocks of machine learning and artificial intelligence, because I'm going to show some tutorials and programming for web developers that revolve around machine learning and artificial intelligence. And I thought I should kick that category off at my website with a history and building blocks video narration. So for web developers, there are a number of ways web developers can implement AI today, covering both the development process and the end user product. Let's briefly discuss a few. 1. Developer productivity, workflow tools. These speed up your development and are often external tools you use. Code assistants, tools like GitHub Copilot or Cursor, generate code snippets, complete functions, and help with debugging. Automated testing. AI-powered tools like AppleTools perform visual and functional testing, spotting UI inconsistencies a human might miss. Design generation. Tools like UWizard can turn hand-drawn sketches or text prompts into interactive digital prototypes. 2. Direct website features. These are features your users interact with on your site. Generative AI chatbots using APIs like Gemini or GPT to power customer support, Q&A, or internal knowledge retrieval. And I've seen that being used on quite a few websites. Personalized content. AI algorithms recommend products, articles, or layouts based on a user's real-time behavior and history. Client-side machine learning. Using libraries like TensorFlow.js, which I'm going to demonstrate in the near future, or ML5.js to run light models like image classification or pose estimation directly in the user's browser, which is fast and privacy-preserving. Smart search. Moving beyond keyword matching to provide contextual, natural language search results. Accessibility. AI generating descriptive image alt text automatically for visually impaired users. So the reason that I've written this video narration with all the images for you guys is because on my website I have a whole new category called AI, and I'll be showing how some things are programmed at the conceptual level, for instance the perceptron, and explaining how it works. And I'm going to move all the way through that concept all the way up to integrating ML and AI APIs onto your website. So subscribe, hit that bell if you don't want to miss any of the content coming through the YouTube channel, or just pop in on my website every now and then. Okay, I hope you've enjoyed this presentation, and I'll be speaking to you again real soon.